Hello, it's great to be here. My name is Akanimo Osutuk. I'm a pediatric doctor in the United Kingdom, and this is my first IOTA hackathon, and I'll be showing and talking to you about my project Anima Health, which is a proof of concept project that uses decentralized identity and verifiable credentials, and also some other cool features to try to enhance the security and safety of healthcare data essentially. That's just a screenshot of a demo which I will be showing to you in a few minutes. Our mission statement. Most of healthcare is quite centralized now, and I think my ultimate vision, like within the next 10 years, would be to live in a world where blockchain has fully got its grasp on healthcare. Um, what's the main problem with healthcare data? We've got multiple fragmentations. We've got data in silos. Take, for example, most of the data, healthcare data for about 60 to 70% of England is housed by Oracle. And because of certain strict rules, most of that data is not interpretable. So if you move, say, to the United States, most of your data gets lost. It then becomes difficult to pinpoint like a single source of truth. Um, then it also does raise a few privacy questions. Centralized databases are quite prone to breach, and also the patients can't really say or talk about how um, give essentially like access restrictions to their data, or say, oh, this institution can have full access to my data while certain other institutions cannot. And there's also the question of trust. Of if I, as a healthcare professional, is viewing a medical record, how can I trust that it has been tampered with after, when it's assumed to be stored in like some data center in London, for example. Um, so hence why um, created this project. You usually get um, in terms of like what we try to do here is we try to create like a proof of concept mini electronic health record that is really privacy centered. So we try to sell it in form of like a vision. Like, what if every patient record had like a way you could cryptographically prove its authenticity, and patients had full power and right over their identity or who has access to their records. And you could actually trust that when you're getting these records back, it's verifiable. And you can also then verify like the credentials of medical professionals on chain. For doctors, we are all under one body, the GMC, which is the General Medical Council. You can verify, um, we all have like special GMC numbers, but in most other countries, it's quite difficult for them to verify if the a doctor is like on a UK register, because it's not like a global thing. Um, so what have we created? What really powers Anima is the kernel. I'll, I'll be walking you through the code at some point, but this kernel is essentially deals with things like authentication. It has like a port service in it, and the port is really unique because it's got Merkle 3 batching implemented in it. It makes use of Redux RS, which is I think is built off Rust. And it also has a module that deals with DID authentication, and it also has a very, very basic patient record management system, because that wasn't what I was trying to focus on this hackathon. So it uses more like a hybrid system where not all of the health data gets stored on chain. Rather, you have an off-chain store that handles the patient data, and then the cryptographic proof and the hashes get stored on specific custom contracts that have built contracts like a DID registry or a consent registry. These are just screenshots of what it does. I would be showing you demo of this. So essentially you authenticate. So what's quite unique is you don't authenticate with like a classic username or password. So you authenticate with like a DID, and then it gives you a challenge, and then you have to sign that challenge. And try to demo this as much as I can with the time frame I have. And there's also a way to verify that the data you stored is authentic. I'll be showing you that in a few minutes. Um, and so, how have we built this? Mostly spent the first week doing lots of research on what are the problems, what's the bare minimum I needed to build to show for this hackathon, and I just decided to focus on proof of data authenticity and data notarization rather than trying to build a whole system. I should rather than trying to build like an entire car, maybe I build like a bicycle that just works. That's one of the advice one of the mentors gave me, and I just followed that. So mostly built out the kernel within the second week, and then some smart contracts during the first and second weeks also. Then in the third and final weeks, we mostly focused on adding cryptographic stuff and working on the front end. So very useful hackathon, very lovely. I think IOTA has one of the most organized docs that I've ever seen. The IOTA identity creates it's flawless, it works really, really well. Found out about new tools like Redoct RS, which I feel that like game changers if integrated properly. I guess it's based on whatever your use case is. And I think IOTA is one of the best blockchains I've used. It's really super easy to deploy contracts with. Moving on to the code base. Um, it's got like three packages in it. So the kernel is like it's like a Rust server that handles most of it has like an API gateway built in it, and it has also a web module, an EHR module that is Open EHR compliant also, although as I said, just bare minimum. There's a DID manager that handles creation and verification of decentralized identity. There's a context module there, um, and there's also a blockchain module. This helps the kernel speak to the deployed contract on IOTA, and also one with OT, but the OT is different, which I will be talking about later. And there's this front end, which I will show you a demo of, and then the contracts, which I focused on building 5 different contracts, one of which is like a DID registry, and like an anchor contract. So when you store the data on this on like a pod or on a local pod, it then Merkle batches them and then anchors it to the blockchain. So it speaks to this contract also, and in the future I hope to implement like a witness and a quorum system where people can then vote to it's just like another extra layer to prove like the authenticity of the data. But I've put my thoughts in what I think it should look like in like designing this smart contract, although for the purpose of this hackathon I haven't fully implemented it yet. And you've also got like a contest attestator contract here, and a governor contract that handles access controls for all the other 4 contracts. So in terms of like working with this repo, there's a README that explains what to do, and how to start, like a quick start guide here, which is like the preferred way to do it. So I've got a tab open here in the terminal. So if you just do cargo run, cargo run starts it up. It initializes the blockchain client, and it initializes most of the modules from the kernel, and yeah, it runs on localhost. I also included like a quick dev folder here, just in case you don't want to you do not want to work with the front end stuff. It's kind of like a quick test. Um, which I've just written to make sure everything works, which you can also run with Cargo Watch, and then it does all of that. And so there's also a login system there with that's time stamped also. The front end app, you can start that also with whichever package manager you like, npm run. And now to show you the demo. So it's currently running on local hosts. The way to authenticate, you have to use a DID. This is the demo default DID for the purpose of this hackathon. So what you do is you request a challenge, and then it gives you a nonce, which expires in about 5 minutes. And then you sign in with your private key, and then that private key gets verified, and then you get a token that gives you a 24 hours access as a healthcare professional. So the challenge has been received, and then this message has been signed. This login process is simulated, and then it verifies that and it logs you in. So you are then greeted with this screen where you can view a patient list of patients that have already been created. You can also add a new patient, which we'll be doing now, and I'm going to call it my name. I can Tony, and date of birth, I'm just going to say I was born last week, MRN 009, gender male, address London. So what happens when you click create? It's updated that, so we've got 4 patients now. So it's created this, it stored this on the Redux bucket. So you can, so this is just showing like the login process, and it stores this on the Redux bucket, which was already synced. So you can see that stored in Redux and with a DID also and a patient ID. Then the next step is then to anchor it to the blockchain. So in order to do that, it already says there's one pending here waiting to be anchored. So if you just create a macro batch, it's anchored it already to the blockchain. So if we go back to the patient list, we see we've got our name here. And if we view the detail, and we can then verify to prove that this data hasn't been tampered with by clicking verify, and then it automatically copies the ID in here, and then you can verify that. It tells you it's been verified, it gives you a few more information, what the ID is, what the leaf hash is, and also the Mecco route. It tells you if verification has been passed, and if it's not passed, it tells you about it. So that's just a quick demo. You can anchor more. You can create like 3 different patients and then anchor all of them all at once. So it's mainly just like a proof of concept to a new way of thinking about how to make how to validate healthcare data and make sure it actually does what it's meant to do, and it's actually stored and retrieved in like a really safe way. Going back to the contracts, it's not just contracts. I've got tests for each and every one of them. So if you just run every single one of them has got contracts, tests, I mean, and I think I've got about 70 tests for all of them. Yeah, so you can just go ahead and run the test. You go IOTA Move tests. It runs the whole test suite, and I think all of them should be passing. Thanks for giving me the opportunity to build this out in the hackathon. Thank you for your time and support and answering my questions in the Discord chat, and can't wait to see what the results are. Thank you.